Okay, so the next part that we have here is new statements from old. So it's about basically the negation of a statement. It's about the negation of a statement. It's about the negation of a statement, and also about compound statements. I think we will talk about compound statements in the next video. About compound statements. About compound statements. And there are some definitions here as well. We'll have to go through all of these step by step and see what we have here. So it says that we now look into a method for producing new statements from those that are that we already have. An English mathematician, George Boole, discussed these methods in his book The Laws of Thought in 1854. So I think basically Boolean algebra, there is Boolean algebra. There is Boolean algebra that must have come from basically from George Boole. George Boole. So it seems that he's written a book, The Laws of Thought, in 1854, and he has discussed these methods in his book, The Laws of Thought, in 1854. And here we will talk about two of such techniques. Now, as a first step in our study of statements, we look at an important technique that we may use in order to deepen our understanding of mathematical statements. As a first step in our study of statements, we look at an important technique that we may use in order to deepen our understanding of mathematical statements. This technique is to ask not only what it means to say that a given statement is true, but also what it would mean to say that the given statement is not true. Okay, so basically it seems that there are basically two things here. Whether you ask what it means. Ask what it means to say that the given statement is true. To say that the given statement is true. And then it basically there is also one more question that you can ask basically whether or what it means to say that a given statement is not true. So whether a given statement is true or not true. So these are two different things, and of course we will see more about what that means. So now about the negation of a statement. So the denial of a statement is called the negation of the statement. So about the negation of a statement. So the definition for that is the denial of a statement. The denial of a statement is the negation of a statement. Is the negation of a statement. For example, let's say that you have this statement over here. For example, New Delhi is a city. So the negation of this statement is it is not the case. It is not the case that New Delhi is a city. That New Delhi is a city. That is the negation of this statement. And you can write this also, basically that you can write as it is false. This statement you can rewrite it as it is false. It is false that New Delhi is a city. That New Delhi is a city. And then this can simply be expressed as New Delhi is not a city. Is not a city. So you add a not. If you basically compare these, the first statement that you had here and this last statement that you have here, you have just simply added the not after is, and that's the negation of your statement. So as a definition, you can say that if P is a statement, you can say that if this is definition 1. This is definition 1. Okay, so now as a definition number 1, if P is a statement, if P is a statement, then the negation of P is also a statement. Then the negation of P is also a statement. Denoted by not P. It's exactly this notation here, not P, and read as not P. So this is read as not P. So as a definition, if P is a statement, then the negation of P is also a statement denoted by not P. And as a note, it says that while forming the negation of a statement, phrases like it's not the case or it is false that is also used, which is basically what we talked about. Now, here we have basically we have an example to illustrate how, by looking at the negation of a statement, we may improve our understanding of it, which is of course very true. Sometimes you don't really realize that you don't really realize what a statement means unless you wrote the negation of that statement, and then from the negation of the statement you could actually then, only then you would understand the actual meaning of the statement itself, the original statement, because some statements are a little bit tricky, and basically when you first read them, you will not, you just will not understand them. The statement is telling you something, you understand something else. It happens many times, especially when it comes to some of these statements, well, at least the ones that I have seen in these mathematics books, basically. So for example, let's say that let's consider, for example, this statement P. Let's consider this statement P that says everyone in Germany speaks German. Everyone in Germany, and of course I'm right now in Germany, and I do speak German. Everyone in Germany speaks German. Okay, so the denial of this sentence tells us not everyone in Germany speaks German. The denial of this would be not everyone in Germany, not everyone in Germany speaks German. This does not mean that no person in Germany speaks German. It says merely that at least one person in Germany does not speak German. So the denial of this, the denial of the statement P, which is everyone in Germany speaks German, is not everyone in Germany speaks German. This does not mean that no person in Germany speaks German. This does not mean no one in Germany speaks German, and by that, basically by that I'm referring to this denial over here. This denial does not mean that basically no one in Germany speaks German. This means that at least one person in Germany does not speak German. So basically you can say that what this means is that there is at least one person in Germany who does not speak German. Who does not speak German. So that's basically that. Now let's see where we are going with this. Now there is one more example. So then basically the original statement was everyone in Germany speaks German, and the denial of that statement was basically not everyone in Germany speaks German, and basically what that means is that there is at least one person in Germany who does not speak German. And of course you need to also pay attention to the fact that you cannot write the negation of this as, for example, everyone in Germany. For example, you cannot say everyone in Germany does not speak German. That doesn't make any sense. I mean, that doesn't make any sense in the case of this sentence. So you need to be careful about that. The negation of, or the denial of, everyone in Germany speaks German, the negation of everyone in Germany speaks German is not everyone in Germany speaks German, right? And you cannot say, for example, you cannot say everyone in Germany does not speak German. What this means is that everyone in Germany is speaking some other language but not German, right? And this is completely different from this sentence. This sentence is saying there is at least one person in Germany who does not speak German, or this sentence, not everyone in Germany speaks German. So these are completely different things, so you cannot there is basically rules of negation. You cannot negate this statement P as this statement. For example, this is actually not P, right? So this is not P. Not P means the negation of P. So you need to be careful about that. But of course, I have already, I think, even in this basically list of videos on YouTube, I have already talked about all of these mathematical logic or something like that. I have already talked about all of those things. I think there is, if you go back and watch those videos, you will learn basically more about logic in mathematics, basically, which is of course an essential part of mathematics. You need to understand that as well. So now let's go and do another example here. Yeah, 379. So now let's consider another example. So you want to write the negation of the following of this statement. So both the diagonals of a rectangle. So you write the negation of both the diagonals of a rectangle have the same length. So now I can, and if I call this, for example, P, the statement P, it says both the diagonals of a rectangle have the same length, meaning that when you have a rectangle over here, these are the diagonals, and both of these diagonals are, meaning that, for example, I call this A, B, C, and D. What that means is that AC is equal to BD, right? That's the meaning of this sentence. Now, I can negate this statement in two different ways. I can say that not both the diagonals of a rectangle have the same length, or I can say that both the diagonals of a rectangle do not have the same length. Now let's see what the answer over here is. It says that this statement says that in a rectangle, both the diagonals have the same length. This means that if you take any rectangle, then both the diagonals have the same length. The negation of this statement is, so this is important. It says this means that if you take any rectangle, then both the diagonals have the same length. The negation of this statement is, it is false that both diagonals in a rectangle have the same length. So the negation, it's always helpful to write the negation not in, basically whenever you're in confusion, it's always helpful to not write the negation in one step. Meaning that first you can say that it is false. It is false that both the diagonals of a rectangle, both the diagonals of a rectangle have the same length, have the same length. It is false that both the diagonals in a rectangle have the same length. And this means the statement and what that means is that this means that there is at least one rectangle whose both diagonals do not have the same length. This means there is, of course this doesn't really mean that. I mean, you could say that, but well, there is at least one rectangle. There is at least one rectangle whose both diagonals do not have the same length. Do not have the same length. So they have written this, the negation they have written it this way because they have assumed that basically they said that both the diagonals of a rectangle have the same length, and then they say that basically this means that if you take any rectangle, then both the diagonals have the same length. So they say that this statement means that if you take any rectangle, okay, if you take any rectangle, the emphasis is on the word any. If you take any rectangle, then both the diagonals have the same length. They say that this sentence means basically this. And so in the negation, this becomes there is at least one rectangle whose both diagonals do not have the same length, which is, well, of course you can say that, but I mean, I wouldn't say that really, unless I was strictly advised that the sentence meant exactly what I wrote over here. Otherwise, I wouldn't say that. But you can basically take the example for what it is and We don't want to create trouble for ourselves, really. That's not really the point. And another example that we have is basically the square root of 7. Square root of 7 is rational. Is rational. Square root of 7 is rational, and we want to write the negation of this statement. Okay, so now about this statement. So basically the negation of this statement may be written as it is not the case. It is not the case that the square root of 7 is rational. Square root of 7 is rational. Is rational. And this can be written as square root of 7 is not rational. So basically this is a good example of negation. Otherwise the example that we had before was a little bit ambiguous. You don't know how to make sense of that sort of thing. So in the case of these 4 examples, what we want to do, we want to write the negation of the statements and then check whether the resulting statements are true or not. So for example, if I say that Australia is a continent, if I say that Australia is a continent, of course, I don't really know if that's the case or not. The negation of the statement is, the negation of this would be it is false. It is false that basically Australia is a continent. It is false that Australia is a continent, which can be written as Australia is not a continent. Is not a continent. Now about whether basically this is true or not, and basically, well, it seems that based on what I read here, this is false. This is false. So so basically the original statement over here, so if I call this P, so then not P would be this, and so if not P is false, then that means that P is true. But there is no indication of that here, right? So I don't really know. Or number 2, there does not exist a quadrilateral. Example number 2, there does not exist a quadrilateral quadrilateral which has all its sides equal, which has all its sides equal. There does not exist a quadrilateral which has all its sides equal. So So what this means is that there is no quadrilateral at all, not even one, in which all of the sides are equal. So of course then the negation of this would be there is at least one quadrilateral in which all of the sides are equal. Now, but we need to go in, basically go step by step. So the negation of this statement is that it is not the case that you can write it is not the case that it is not the case that, and then you just simply add this sentence, this whole sentence down here. So it is not the case that there does not exist a quadrilateral which has it is not the case that there does not exist a quadrilateral which has all of its sides basically equal. And so again, I read this sentence again. It is not the case that there does not exist a quadrilateral which has all of its sides equal. And basically then you can rewrite this sentence as there exists a quadrilateral. There exists a quadrilateral. There exists a quadrilateral which has all its sides equal. Which has all its sides equal. Which has all its sides equal. And this statement is true because, for example, in a square, all of the sides are equal. So that means that this original statement over here was false. This was false, and this one is true. If this one turns out to be false, then that means that this one was true. So basically, whenever you have P and not P, if P is true, not P is going to be false. If P is false, not P is going to be true, and vice versa. So that was number 2. Now number 3 is every natural number is greater than 0. Every natural number is greater than 0, which is of course true. It's a true statement. So to negate this, you can say that it is false that every natural number is greater than 0. You can say that it is false that every natural number is greater than 0, and which can be rewritten as there exists a natural number. There exists a natural number which is not greater than 0. Which is not greater than 0. Okay, greater than 0. Which is a false statement. This is a false statement. There is no natural number that is greater than 0. I'm sorry, there exists a natural number there exists a natural number which is not greater than 0, which is false. There is no natural number that is not basically greater than 0. All natural numbers are actually greater than 0. So since this is false, that means that this was true, and if you check this original statement here, you can actually see that the original statement was actually true, meaning that every natural number is greater than 0 is actually a true statement. Since this is a true statement, if I call this P, and then if I call this naturally not P, then when not P is false, then P is basically true, and vice versa, of course. And we have another statement here that says that the sum of 3 and 4 is 9. The sum of 3 and 4 is 9. Of course, we know that this is a false statement, because the sum of 3 and 4 is actually 7. So then for the negation, you can say that it is false. It is false that the sum of 3 and 4 is 9. That the sum of 3 and 4 is 9. And then you can say that the sum of 3 and 4 is not 9. Or not equal to 9, we can say, of course. Not equal to 9. Not equal to 9. Which is a true statement. That means that this statement was false. This is a true statement. Okay, so I think that's enough for this video. In the next video we will talk about, so this was all about the negation of a statement. In the next video we will talk about compound statements, which are actually interesting statements. Compound statements. We will talk about this in the next video. So I'll see you in the next video.